original one P, that means this is 1/3 of the P. That makes this one half of the original power, and this one 1.5 or 3/2 of the original power. So A, B, C, D. A would be P, B we just said was 1/3 the power of A, this one is half the power of A, and this one is 3/2 or 1.5 the original power of A. Alright, so each circuit is connected to a battery with a starting voltage of V. So voltage meaning like the difference in potential energy of the charges from one point of like one side of the battery to the other. So like basically your starting potential energy. If each circuit is connected to its battery at the same time, we're going to rank each circuit for the length of time the bulbs are going to remain lit. So like which circuit will the bulbs have current flowing through them remain lit the longest to the least amount of time. So this has to do with power, obviously, because part A is I asked you to find the power, but how you would have known, other than I asked you to determine it, is power is the rate that energy is used up, or energy is, we'll say, dissipated. Technically, the battery is providing the power, delivering the power, the resistors are using it up. So you could have said delivered, or is that what I said? Yeah, the battery is the rate that they're delivering it. Either way works, but the point we're trying to make here is that the rate depends on the time. So they're all starting with the same like total amount of energy, but some of them are using it up at faster rates, this guy, than others. Some are using it up at slower rates than others. So if they all start with same voltage, so the same amount of like energy at the start, the one that lasts longest is the one that, how would we say that you delivers energy at the slowest rate, which is the one with the lowest power. The battery that dies first is the one that, sorry, terrible handwriting, but you can hear my words. So the battery that dies first is the one that delivers energy at the fastest rate, which would be highest power, because we'll run out of energy first. So the longest amount of time would be the slowest, the one that's using energy at the slowest rate, that would be B, then C would be next, then A, and the one that's using it at the fastest rate is D. So the one that delivers energy at the slowest rate, the lowest power, that was B. The one that was the highest power, that was D right here. So that's our justification. It had to do with the power, the rate that it's using energy. Alright, and then the sheet I gave you guys today in class, so just because it takes me a really long time, it's awkward writing slowly on the video, I actually already wrote it out. So the idea here is students want to know how the current is affected when resistors of greater resistance are placed in series in a circuit. They've got a variable power supply, variable meaning it can change, and power supply is like basically a voltage source, so it provides like power in this like voltage specifically, because voltage provides current and then therefore provides power. So we've been using just batteries, they have the same voltage. A variable power supply means you can change the voltage, that's it. It has like a little dial that you can say 1 volt, 2 volt, 3 volts, etc. You've got a bunch of resistors, wires, voltmeters, ammeters, and standard lab equipment. A voltmeter, let's make a note here, measures voltage. An ammeter, hopefully you can figure this out, measures amps or current, because amps, current is measured in amps. And then variable power supply is basically like your voltage source. It's just that it can change. So you could have like, it's not the same, a battery has 1.5 volts. It's always going to have 1.5 volts until it dies. This one I can do a bunch of different power or voltages. All right, our two questions we want to answer. Does current through the circuit stay the same when there is a greater resistance in the circuit? Does voltage across the resistor stay the same when there is a greater resistance in the circuit? All right, so we want to design and describe an experimental procedure that can answer the two above questions, describe the equipment you would need, include a neat labeled diagram, and what measurements you would need to make, include enough detail another student could replicate. All right, so first, like, what should your setup look like? So I said that we would, of course, need a power supply. You'd need a resistor in series, so like set up the wires, power supply, and resistor in series. And because we're going to need to measure current and voltage, we need our voltmeter and our ammeter in our circuit. We talked about, this is like the first day of electricity, when we were doing the lab, I told you the ammeter, this is like the symbol for ammeter, and this is the symbol for voltmeter. Pretty straightforward. If you had forgotten, you could say like ammeter or something like that, just so that they know this is supposed to be an ammeter or voltmeter, etc. These are our standard physics symbols for ammeter and voltmeter. So I said the first step would be connect the power supply, a low resistance resistor, because we're going to be increasing it, so I just said the lowest resistance resistor. He didn't have to specify that, but can't hurt. And an ammeter in series using the wires, not just one wire, wires. Place the voltmeter in parallel across the resistor. So first let me show you what that looks like before I explain why ammeters in series and voltmeters in parallel. So I've got my power supply, that's like my battery, it's just, I can change the voltage. And I've got wires, resistor, so this resistor is in series with my power supply. And then because I need to measure current and voltage, I put my ammeter and my voltmeter in. The ammeter is just part of the circuit because it measures the current, so I'm just going to split that, insert that in. It doesn't matter where you put it. You could have put it before the resistor, anywhere in here, or you could have put it after the resistor because we know that the current's going to be the same because it's in series, but doesn't matter. I would do it just before so you know like what current is going into the resistor. And then the reason my voltmeter is not inside the circuit, remember the definition of voltage or potential difference is the difference in potential energy of charges from one point to another. So I'm saying what is the difference in potential energy from here to here? So I can't have it like voltage right here because that would be like saying, okay, from this side of the voltmeter to this side. Well, that's just inserted in like with the wires, there's not going to be any voltage. That would be like saying, okay, from here to here. Well, if it's just a wire, then the potential difference is zero, right? Nothing is happening right there. The energy isn't changing here. So I'm going to cross that off. The idea is it has to go from one point to another, and I want to know the voltage across the resistor. So it has to go from one side of the resistor to the other. That's how I'm going to get the potential difference across the resistor. Okay. And then you would need to measure the things you're going to need to record or measure. You need to measure the current that the ammeter reads and the voltage across the resistor, which is what the voltmeter reads. So those are the two things you need to record. And then what you're going to need to change is, okay, well, we're going to replace the resistor with a resistor of higher resistance, and then, again, repeat. So put in a new higher resistor, measure the current and the voltage there. Okay, put in another resistor, measure the current and the voltage there. Explaining how the measurements shown could be used to answer question A. Well, question A said, or asked, does current through the circuit stay the same when there is a greater resistance in the circuit? So it's pretty easy to answer that question. If you increase the resistance, which is what we said we would do, we would replace the resistors with higher resistance, and then we measured the current. So if for each resistor the ammeter measures the same current, then yes, current stays the same when there is a greater resistance in the circuit. Question B, does the voltage across the resistor, so it's just one, stay the same when there is a greater resistance in the circuit? So we would know if for each resistor the voltmeter measures the same voltage, then across the resistor, I should have said across the resistor. Then the voltage, oh, I guess I said it right here. Then the voltage across the resistor stays the same when there is a greater resistance. So pretty straightforward, whether that would like be a yes or no answer based on the data that we took. Last one is a student wants to know if the current through the circuit stays the same when the voltage of the circuit is increased. How would the experiment need to be changed or adjusted in order to answer this question? So here, I'm still measuring current, so I want to know how current is affected when the voltage is increased. So this is where it is important, or like it's helpful that we had a variable power supply, because I can change the voltage really easily. It's not that I have a bunch of batteries, because I could just do a bunch of different batteries, but I have a variable power supply, so I can just increase the voltage on the in this circuit. So I'm going to use the variable power supply to increase the voltage. So like just do a couple different voltages. I'm going to keep the same resistance because I want to know that it was increasing the voltage that made the current change or stay the same, etc. So it doesn't matter what resistor you use as long as you keep it the same. And then the thing we're going to be measuring, well, we still need to measure the current. We don't need to measure the voltage anymore. It can't hurt, so you don't need to say, like, I have to stop measuring the voltage, because you can still measure it. You just don't need it. You do absolutely still need to measure the current because that's what you are looking for.